By the end of this video, you will understand how API testing works, and you will have written real automated API test in Rest Assured. Not a toy diagram that stops before the useful part. You will see a request leave a client, travel through an API, reach business logic and data, and return as a response. Then we will turn that mental model into Java code that checks a real practice service. We will make the first test pass, deliberately make it fail, and then add assertions for the response body, headers, and response time. Finally, we will send a post request with a JSON body and verify the precise status code that a create operation should return. This lesson is built for manual testers moving into automation, junior SDET engineers, and anyone preparing for a software testing interview. You do not need previous API automation experience. I will explain the vocabulary before I use it, and when we reach the code, I will slow down and connect every line to the fundamentals. Keep a code editor nearby if you want to follow along. The goal is not to memorize a finished file. The goal is to understand why the file works, so that you can adapt it when an interviewer or a real project changes the endpoint. Here is the route. First, we will build a clear model of a web application, the client, the server, and the three layers that sit between a user action and stored data. Second, we will define an API in practical language and look at what API testing actually validates. Third, we will cover the HTTP essentials, methods, status codes, headers, and JSON. Fourth, we will set up a small Maven project with Java, TestNG, and Rest Assured. Fifth, we will write a get test, strengthen it with realistic assertions, and add a post test. Notice the order. Tools come after concepts. A tool can help you send a request, but it cannot decide whether the response is correct. That judgment comes from understanding the contract. By the end, you should be able to explain given, when, and then without reading notes. Distinguish a 200 from a 201, navigate nested JSON with dot notation, and explain why a reliable API test gives a team faster feedback than a browser-only test. Every API test becomes easier once client and server are clear. A client is the thing asking for something. In a web application, that may be a browser. In a mobile product, it may be the app on your phone. In an automated test, the client is your test code. The server is the system that receives the request, applies rules, reads or changes data, and sends a response. Think about opening a user profile. The client sends a request that means, give me user number 3. The request contains an HTTP method, an address, and sometimes headers or a body. The server receives that message, decides whether the caller is allowed, finds the data, and returns a response. That response has a status code, headers, and usually a body. The arrows matter. The client does not receive a magical screen. It receives a structured response and then decides what to display. API testing lets us inspect that exchange directly. We can ask the server a precise question and check the precise answer without waiting for a browser to draw buttons, colors, and layout. Let us make the request and response concrete. A request starts with a method such as get or post. It targets a URL, sometimes with a path parameter such as the number 3 in users/3. Headers carry metadata, the type of content being sent, the response formats the client accepts, or an authentication token. A request body is optional. A get usually has no body. A post often has a JSON body describing the resource to create. The response has its own 3 areas. The status code gives the high-level outcome. 200 means the request succeeded. 400 and 500 families describe different classes of failure. Response headers tell the client how to interpret and cache the response and may expose important security behavior. The response body contains the returned data or an error object. As a tester, never collapse all of that into the sentence. The endpoint worked. Ask, did it return the right status, the right headers, the right data shape, the right values, and the right error when the request was wrong? That is the beginning of a useful test. Most web applications can be understood as 3 layers. The presentation layer is what the user sees, HTML and JavaScript in a browser, or the screens of a mobile app. Its job is to collect input and present output. It should not own the core business rules. The business or API layer sits in the middle. This is where rules live. Can this customer place the order? Is the discount valid? Does this account have permission to view the record? This layer coordinates work and exposes operations through endpoints. The database layer stores the durable data: users, orders, products, permissions, and audit records. The API layer talks to the database through application code or data access components. The presentation layer does not directly execute database queries. This separation is not only architecture theory. It gives a tester multiple places to observe quality. UI tests check the whole experience, but they are slower and sensitive to layout changes. API tests target the rules below the interface. Database checks can confirm persistence when appropriate. A balanced strategy uses each layer for the evidence it is best at providing, instead of forcing every scenario through the longest path. Here is the key insight, and it is worth slowing down for. The user interface does not talk to the database directly. It goes through the business and API layer. That means if you test only through the UI, you are exercising the slowest and often the most fragile route to logic that lives somewhere else. Imagine a rule that rejects an invalid postcode. A browser test has to launch a browser, wait for the page, locate fields, type values, click a button, and wait for rendering before it can observe the rule. An API test can send the same invalid value directly and receive the error in a fraction of the time. The API test is less likely to break because a designer moved the button. This does not mean UI testing is unnecessary. Users still need a working interface. It means you place most rule-level coverage below the UI and reserve end-to-end browser tests for critical journeys and integration confidence. In an interview, that distinction shows that you understand test strategy, not just syntax. The question is always, what is the fastest stable layer that can prove this behavior? A price comparison site makes the model visible. A user enters a route and dates once. The interface may then trigger calls to many providers. Each provider applies its own availability and pricing rules and returns structured data. The comparison service may normalize those different responses, sort the results, add fees, and send one combined response to the page. The page then renders cards, filters, and prices. If a displayed fare is wrong, the defect could sit in several places. A provider may have returned incorrect data. The aggregation API may have mapped a field incorrectly. The sorting logic may be wrong, or the UI may have formatted a valid value badly. An API test helps isolate the layer. You can inspect the provider response, the combined response, and the front-end display separately. That diagnostic power is one reason API skills are so valuable to an SDET engineer. You're not merely finding that the page looks wrong. You're narrowing down where the behavior changed. API stands for Application Programming Interface. The expanded words matter less than the idea. An API is a controlled interface that lets one software component ask another component to perform an operation or return data. It acts as a mediator between the front end and the systems behind it. The word contract is useful. A contract says which method and path to call, what headers or authentication are required, which fields belong in the request, and what responses are possible. For example, the contract may say that getUsers/3 returns a user object when the user exists, and a not-found response when the user does not. Testing that contract means checking both sides. Valid input should produce the documented success response. Invalid or unauthorized input should produce the documented error response. Fields should have the expected names and types. Required fields should actually be required. Optional fields should behave consistently. Once you think of an API as a contract rather than a mysterious pipe, test design becomes systematic. Identify each promise, then create evidence that the promise is kept. You use APIs every day without seeing them. At checkout, choosing a card may send data to a card payment service, while choosing bank transfer may call a different banking service behind the same page. A flight aggregator asks several travel providers for availability. A banking app may call separate services for balances, payments, identity verification, and notifications. The interface simplifies all of that for the user. It may show one button, but the button can trigger several network operations. This is why a screenshot is weak evidence for many behaviors. The final screen may look correct even if an intermediate service returned a warning, a cached value, or a field in the wrong format. API testing gives you visibility into those boundaries. You can verify what was sent, what came back, and how failures are handled. When a third-party payment service is unavailable, does the application return a controlled service unavailable response? Or does it expose a stack trace? When a bank rejects a transfer, does the customer receive an accurate message? Those are contract and error handling questions, and they live at the API boundary. You will meet several access models. Public or free APIs may allow limited use without an account. They are ideal for practice, although they often rate limit traffic. Protected APIs require an API key, a session, or an access token. The credential tells the service who is calling and what the caller is permitted to do. Private internal APIs are used inside an organization and are not intended for public discovery. As a tester, you may receive access to internal endpoints that ordinary users never see. That is a responsibility. Use approved environments and test accounts. Never place real secrets in source control. Store credentials in environment variables or a secure secret manager, and make sure logs do not expose tokens. The core testing questions remain consistent. Does valid authentication succeed? Does missing or expired authentication fail with the correct status? Does one role stay out of another role's data? Public, protected, and private describe who can call the service. They do not remove the need to validate the contract, data, errors, security behavior, and response time. API testing means sending requests directly to the API layer and validating the responses, without using the graphical interface as the driver. Directly does not mean carelessly. A well-designed API test prepares known input, sends one meaningful action, and checks the observable contract. Start with the status code. Did the operation succeed or fail correctly? Then inspect the body. Are the right fields present? Are values correct? Are data types and nested structures what consumers expect? Inspect headers. Is the content type JSON? Are caching or security headers appropriate? Consider response time. A functionally correct service that consistently takes 30 seconds may still be unusable. Finally, test negative cases. Wrong input should produce a controlled, useful error, not an unexpected server failure. Those dimensions work together. A 200 response with the wrong user is not a pass. A correct body returned with a 500 status is not a pass. A 404 that leaks internal database details is not a pass. Good API testing checks the whole response and connects every assertion to a requirement or a risk. Let us turn the 5 dimensions into a review habit. First, status. A success endpoint should use the documented success code, and each failure mode should use the documented error code. Do not accept any 200 family code merely because it is green. Second, body. Check critical values, not every character. Validate identifiers, business outcomes, required fields, data types, and nested objects. Overly broad exact response comparisons become brittle when harmless fields change. Third, headers. Content. Type tells the client how to pass the body. Cache headers can affect whether users see stale data. Security headers and correlation identifiers may be part of operational requirements. Fourth, time. Choose a threshold that comes from a requirement or an agreed service objective. A 2-second assertion in a tutorial demonstrates the technique. A production threshold should be justified and stable in its environment. Fifth, negative behavior. Remove a required field. Use an invalid identifier. Send malformed JSON. Try an unauthorized role. Confirm that the API rejects the request safely and consistently. Negative testing is not trying random bad values until something breaks. It is modeling realistic misuse, boundary cases, and dependency failures, then checking that the service remains controlled. API tests are usually faster than browser tests, because they do not launch and render a full interface. They are often more stable because a CSS selector or layout change cannot break them, and they can run earlier. A team can exercise a back-end endpoint before the final page is designed, which moves defect detection closer to development. That makes API automation valuable in continuous integration. A focused suite can run on every change and provide feedback while the developer still has the context in mind. Browser tests remain important, but a small set of critical journeys is easier to maintain than thousands of UI checks that duplicate business rule coverage. For your career, the value is not simply knowing a library, it is being able to reason below the UI. In an interview, explain the trade-off. API tests give fast and focused contract evidence. UI tests prove that the assembled user journey works. Neither replaces thoughtful exploratory testing. Teams pay for engineers who can choose the right layer, diagnose failures, and build feedback that people trust. HTTP methods describe the intended operation. The common mapping is CRUD. Create, read, update, and delete. Post usually creates a new resource. Get reads a resource or collection. Put replaces the full representation at a known location, while patch applies a partial update. Delete removes a resource. Treat that as a strong convention, not a substitute for documentation. Real APIs can use specialized actions, and the contract tells you the expected behavior. Still, method semantics guide test design. A get should normally be safe. Reading a user should not change that user. Repeating the same get should not create duplicates. A successful post often returns 201 created and may include the new identifier. An update should change the requested fields and preserve the others according to the contract. A delete may return a body or may use 204 no content. When you design tests, connect the verb to state. Before a create, the resource does not exist. After it, it does. Before an update, a field has one value. After it, the field has another. The response is important, but the business state is the real outcome. Status codes group outcomes into families. 200 codes indicate success. 200 OK is common for a successful read or update. 201 created is precise for a successful creation. 204. No content means the operation succeeded and there is intentionally no response body. 400 codes describe a problem with the request or the caller's ability to perform it. 400 bad request often covers invalid syntax or validation. 401 means authentication is missing or invalid. 403 means the caller is known but forbidden. 404 means the target resource was not found. The memorable shortcut is 4xx, fix your request. But remember that a client error can still reveal a server defect if the API returns the wrong code or an unsafe message. 500 codes describe a server-side failure. 500 is a generic internal error. 503 indicates that the service is unavailable, perhaps because a dependency is down or the service is overloaded. The shortcut is 5xx, raise a bug, or investigate the service. Precision matters. If a post creates a resource but your test accepts 200 when the contract requires 201, the test is hiding a contract defect. Assert the code, you mean. JSON is the data format you will see in most modern web APIs. A JSON object uses curly braces and contains key-value pairs. The key is a string such as name. The value can be a string, number, boolean, null, another object, or an array. An array uses square brackets and holds an ordered list of values. Imagine a user response. At the top level, name may map to Clementine Bauch. Address may map to another object. Inside address, city maps to Mackenzie Haven. In a query language such as JSON path, address.city means enter the address object, then read its city field. If the response contains an array of users, an index or a filter can select the item you need. 3 beginner errors are common. First, confusing JSON object braces with array brackets. Second, expecting a number when the API returns a quoted string. Third, treating a nested field as though it were at the top level. Read the punctuation and indentation. A good API test validates meaningful paths and types instead of comparing one enormous raw text block. A browser address bar can demonstrate a simple get. Paste a public get URL, press enter, and the browser sends a request and displays the response. But the address bar is designed for navigation. It does not give you a practical way to create a JSON body. Choose arbitrary methods such as post, put and delete, or manage test assertions. Postman is excellent for exploring an API by hand. You can set methods, headers, parameters, and bodies, inspect responses, and learn a contract quickly. Keep it in your toolkit. But repeatable automation is where tests run without you, on a pull request, every night, or before a release. Rest Assured is a Java library for that automated layer. Its style is readable. Given some setup when an action occurs, then check the result. The library integrates with test runners and matches, so API requests become maintainable test code. The point is not Postman versus Rest Assured as a winner-takes-all contest. Use a manual client to investigate and prototype. Use code when the check must be repeatable, reviewed, versioned, and run in continuous integration. For the project, install a Java Development Kit version 17 or later, Maven, and IntelliJ IDEA Community Edition. The JDK compiles and runs the Java code. Maven manages the project structure, downloads libraries, and runs lifecycle commands. IntelliJ is the editor and development environment. The free Community Edition is enough for this lesson. Before creating the project, verify the tools in a terminal. Java Dash version should show a JDK of 17 or later. Maven Dash version should display Maven and the Java runtime it is using. If Maven points to a different or older Java installation, fix that before debugging test code. Many beginner setup problems are environment problems in disguise. Create a new Maven project. Use a simple group identifier such as com.example and an artifact name such as API tests. Keep the default source layout. Production code belongs under source main Java. Test code belongs under source test Java. We will place first API test under the test folder because rest assured and testng are test dependencies, not application features. Maven gives the project a shared recipe. Instead of downloading jar files by hand and hoping every machine has the same versions, we declare dependencies in pom.xml. Maven resolves those libraries and their transitive dependencies. A teammate or a CI agent can clone the project and run the same build command. The POM also records project settings such as the Java language level and plugins. For a learning project, keep it small. The important idea is reproducibility. If a test works only because your laptop has an untracked library somewhere on disk, the project is not ready for a team. After you add dependencies, allow IntelliJ to reload the Maven project. You should see the libraries appear in the project view, and the imports in your test file should resolve. From a terminal, Maven test is the key command. It compiles test sources and asks the configured test framework to run them. Later, the same command can live in a continuous integration pipeline. Inside the dependencies section of pom.xml, add two entries. The first is rest assured, using groupio.restassured, artifact rest assured, and the pinned version 5.5.0 from this lesson. The second is testng, using grouporg.testng, artifact testng, and pinned version 7.10.2. Both entries use test scope. Scope tells Maven that these libraries are needed to compile and run tests, but they should not be packaged as part of an application. That is exactly what we want. Rest assured gives us the fluent API for building requests and validating responses. Testng discovers methods marked with the test annotation and reports whether each test passed or failed. Hamcrest matches, which rest assured uses for expressive assertions such as equal to and not empty, are available through the testing dependencies. Use the exact version shown if you want to reproduce the lesson. In a real codebase, dependency updates should be reviewed and tested deliberately. Do not change versions mid-tutorial, and then assume an unrelated compilation problem comes from your Java syntax. Reload Maven. Wait for dependency resolution, and check that the editor no longer marks the imports as missing. We will use JSON placeholder, a public practice service that exposes familiar resources such as posts, comments, and users. It requires no authentication for this tutorial, so we can focus on the mechanics of requests and assertions. Our first endpoint is users/3. The expected user has the name Clementine Bausch, an address object whose city is Mackenzie Haven, and a nested company object. Later, we will post to users. The service simulates creation and returns an identifier, but it does not persist a real new account. That behavior makes it convenient for learning and also teaches an important lesson. Know your test environment. An assertion that proves a simulated endpoint returned 201 is not evidence that a production database committed a record. Public practice services are shared resources. Keep request volume reasonable and never build a business-critical pipeline that depends on a free external demo. For a real project, use an approved environment and controlled test data. Create a class called firstAPITest under source test Java. Import the test annotation from testng. Then add static imports from rest assured and Hamcrest so the fluent methods and matches remain readable. The class contains a test method named getUserReturns200 and correct name. A descriptive name tells us the action and expected outcome. The test annotation tells testng to run it. Inside the method, given starts the request setup. Base URI points to the JSON placeholder host. When begins the action, and getUsers/3 sends an HTTP GET to that path, then begins validation. Status code 200 checks the high-level success outcome. Body name equal to Clementine Bauch navigates to the top-level name field and compares its value. Notice what is not in the test. There is no browser driver, no element locator, and no wait for a page to render. The test speaks directly to the service. Also notice that we assert both status and content. If the server returned a different user with status 200, the status assertion alone would miss the defect. The name assertion gives the test business meaning. Given, when and then are more than attractive formatting. They separate three responsibilities. Given describes preconditions and request setup, the base address, authentication, headers, parameters, and body. When describes the one action under test, send a get, post, put, patch, or delete. Then describes observable expectations. Read the first test as a sentence, given the JSON placeholder base address. When I get user 3, then the response status is 200 and the name equals Clementine Bauch. If you can explain that clearly in an interview, you are showing that the code expresses behavior. Keep the action focused. If one test sends 5 unrelated requests and has 20 loosely connected assertions, a failure becomes difficult to diagnose. Setup can create necessary state, but the central behavior should remain obvious. The style also supports reuse later. A request specification can hold common setup. A response specification can hold shared expectations. Helper methods can create data. But do not rush into a framework before you understand the simple flow. First, make one readable test work. Then remove duplication when you can see what is genuinely common. Run the test. Maven or IntelliJ compiles the class. TestNG discovers the annotated method. Rest assured sends the request, and the assertions evaluate the response. When it passes, pause on what happened. An automated API test checked a live HTTP exchange in seconds with no user interface. Now prove the test can detect a problem. Change the path from users/3 to users/999 while leaving the expected status at 200. The practice service returns not found, so the status assertion fails. Read the failure message. It should tell you that the expected status was 200 and the actual status was 404. This deliberate failure is not theatre. It verifies that the test is connected to the behavior you think it is checking. Restore users/3 and run again. Green after a controlled red is more trustworthy than green you have never challenged. In real work, avoid leaving deliberately broken values in the main branch. Use the experiment locally, understand the failure, then restore the correct test. The lesson is to validate the validator. The first test is a useful smoke check, but production tests usually need more evidence. Add a second TestNG method called getUserValidates body headers and time. We will still call the same user endpoint, but this version demonstrates reusable path parameters, nested JSON assertions, a header check, and a response time threshold. Resist the urge to assert every field merely because it exists. Choose fields that prove the behavior. The city shows nested navigation. A non-empty company name checks that a required business value is present without coupling the test to one exact company string. Content type confirms the representation is JSON. Response time demonstrates a lightweight service expectation. Every assertion has a maintenance cost, so each should answer a question. If this assertion failed, would the failure reveal a meaningful defect or contract change? If the answer is no, the assertion may be noise. Strong tests are precise, but precision is not the same as comparing everything. In given, add path param with the name ID and value 3. In the get path, replace the hard-coded number with braces around ID. Rest. Assured substitutes the value when it sends the request. The final network call is still users/3, but the test data is separated from the root template. That separation becomes valuable when the identifier comes from setup, a data provider or a previous create operation. It also reduces risky string concatenation. Make sure the placeholder name and path parameter name match exactly. Now inspect the nested body assertions. Address.city uses JSON path to enter the address object and select city. We expect Mackenzie Haven. Company.name enters the company object and selects name. Instead of checking one exact value, not empty string verifies that the field contains something meaningful. JSON path is a high-value interview topic because API responses are rarely flat. Practice objects, arrays, indexes, and filters. But keep readability in mind. If a path becomes extremely complex, extracting the response into a typed object or a helper may communicate the intent more clearly than one long expression. The header assertion asks for content type and checks that it contains application/JSON. Contains string is practical because a server may append a character set such as UTF-8. An exact equality check could reject a perfectly valid content type with additional parameters. Choose the matcher that expresses the requirement. The time assertion checks that the response completes in less than 2000 milliseconds. You have just added a mini performance check to a functional test. That is useful as an early warning, but it is not a replacement for load testing. One request from one machine cannot prove throughput, scalability, or behavior under sustained traffic. Response time assertions can also become flaky when they use arbitrary thresholds in noisy shared environments. In a real project, derive limits from service objectives, measure the environment, and separate strict performance suites when necessary. The tutorial threshold demonstrates the API and makes the expectation visible. Run the test and read each assertion as evidence. Correct status, correct representation, correct nested city, non-empty company name, and acceptable duration. If one fails, the report points to a specific dimension of the contract. For the first post, create a Java text block called new user. The JSON object contains name Mitchell, username SDET Coach, and email test at example.com. A text block keeps multi-line JSON readable, but it is still a string. In larger test suites, you may serialize a Java object or use a builder so test data is typed and reusable. The request body describes the resource we want to create. Test data should be intentional. Include required fields, vary optional fields in separate cases, and use synthetic addresses rather than real personal data. If the API requires uniqueness, generate a controlled unique value and make cleanup part of the design. Before sending the request, check the JSON punctuation. Property names and string values use double quotes. Pairs are separated by commas. The final pair does not need a trailing comma. A malformed body should be a deliberate negative test, not an accidental syntax error in the happy path. We will send this representation to the user's collection. The endpoint, method, and body together communicate. Create a new user from this data. The post test follows the same story. Given the base URI, set content type to application/JSON and attach the new user string as the body. When we post to users, then the response status should be 201 and the returned ID should not be null. Content type is one of the most common beginner mistakes. It tells the server how to interpret the bytes in the body. If you send JSON without declaring JSON, the service may reject the request, treat it as plain text, or use a default you did not intend. The header is part of the contract. The expected status is 201, not a vague success check and not automatically 200. Created is the precise outcome for this contract. The body assertion checks that the service returned an identifier. In a real persistent service, you might then get that identifier and verify the stored representation, or query through an approved interface. You might also check a location header if the contract provides one. Run the test. The important pattern is reusable. Prepare valid JSON, declare its content type, send post, assert the precise creation response, and verify the key business result. JSON placeholder fakes the creation response. It returns the shape and status we need for practice, but it does not create a durable production user. Say that honestly. A passing test proves that our client sent the request and that this practice endpoint returned the expected simulated contract. It does not prove database persistence. Real APIs add more concerns. Authentication tokens identify the caller. Authorization rules limit which records the caller may create or view. Data may need cleanup after the test. Duplicate requests may require idempotency handling. Dependencies may time out. Logs and correlation identifiers may be needed to investigate failures. Those topics belong in the next session with put, delete, and a maintainable framework. For now, keep the learning boundary clear. You can send get and post requests, parameterize a path, validate nested JSON, inspect a header, check a response time, and distinguish 200 from 201. That is a solid first session. Let us connect the whole lesson. A client sends an HTTP request and a server returns a response. Web applications separate presentation, business or API, and database concerns. The user interface goes through the API layer, so rule-level testing is often faster and more stable below the UI. An API is a contract between software components. API testing sends requests directly and validates status, body, headers, response time, and negative behavior. HTTP methods express intent. Post creates, get reads, put or patch updates, and delete removes. Status families distinguish success, request problems, and server failures. JSON represents data through objects, arrays, and key-value pairs. In code, given describes setup, when sends the action, and then checks the result. Your first get asserted status 200 and the correct name. The stronger get used a path parameter, JSON path for nested fields, a content type header assertion, and a response time check. The post declared a JSON content type, attached a body, expected 201 created and verified that an identifier was returned. That is practical API testing knowledge you can demonstrate, explain, and build on. These concepts appear constantly in SDET interviews. You may be asked to map HTTP methods to CRUD, distinguish 401 from 403, explain why post often expects 201, navigate nested JSON, or describe given, when, and then. A strong answer does more than recite a definition. It gives a small example and states what the test would prove. For example, I use a path parameter when the root varies by identifier, because it separates test data from the endpoint template. I assert content type because the client needs to pass the representation correctly. I test negative input because a controlled 400 is part of the contract and is safer than an unexpected 500. I keep most business rule coverage at the API layer because it is faster and more stable, while preserving a focused set of end-to-end UI tests. Practice saying those answers aloud, then write one variation of each test without copying. Change the user identifier, add another nested assertion, and create a negative case with an invalid path. The movement from recognition to recall is what makes the knowledge available under interview pressure. One last thing, and it is the reason this channel exists. Status codes, given when then, JSON path, and the difference between 200 and 201 are exactly the questions you will face in SDET interviews. SDET Coach is a practice question bank built around the skills employers actually ask for: API testing, REST assured, Playwright, Java, and more, with explanations that teach why an answer is correct, not only what to select. It also helps you compare your skills with real SDET job requirements so you can identify the gaps that matter first. Search for SDET Coach on the App Store or Google Play, or use the links in the video description. Do 10 API testing questions after this lesson, while the ideas are fresh. In Session 2, we will add authentication tokens, put and delete, and organize the test into a framework you could show an employer. Subscribe so the next session lands in your feed. You now have the model, the vocabulary, and 3 working test patterns. Keep the code, change one thing at a time, and make every assertion explain what it proves. See you in Session 2.